All right, algebra fans, we've got chapter 7, section 2 rolling today, and we are only going to cover part of the notes that you have on your sheet. Again, this year we're looking to take things out that, maybe a little bit of an extension of what we're working on. So we are actually going to begin halfway down your note sheet where it says scientific notation. That's where we're going to start. So you can put a big X through the powers of 10 section there in the top half. So we'll cover the scientific notation, and then we are actually going to skip the last set of examples also where it says order the list of numbers from least to greatest. So we are only going to cover this little middle section here, writing numbers in scientific notation, given a number in standard form, and then working backwards. If you're given a numerical value written in standard form as a number, you are going to want to write it in scientific notation. You have probably seen scientific notation before, and where it is used is to truncate or make a really large number that might be like the distance from Earth to another planet in feet or miles, a really large number. You can use scientific notation to write it in a shorthand notation. Also, if you have a really small number, like a decimal that's like 0.0000, the weight of a molecule or something of that nature, something really small, or a minute measurement, you can also use scientific notation to write that number so it doesn't take up so much room on your sheet of paper. So scientific notation, we have what we call our C value. Now C is what I call the leading number before my times 10 to a power. Now it's really important here that C, the number that is in front of times 10 to a power, is a single digit numerical value, meaning it's at least equal to 1 but less than 10. So it's between 1 and 9.9999999. So as you look at the first four examples here, we have a number, our C value, the number in front of the times 10 to a power, that is a single digit number, meaning it's a number between 1 and 9.99999, 2.38, 7.8, 4.9, and 1.23. Awesome. So what this tells us is if we have a number in scientific notation, I can take my C value, the number that is in front of times 10 to a power, and I can move my decimal place, the exponent number of place values, and that will give me the given scientific notation value in standard form. The catch is looking at the sign of your exponent. If it is a positive exponent, I am going to move that many decimal places to the right. If it is a negative exponent, I will move that many decimal places to the left. So let's practice a little bit here. I've got 2.38 times 10 squared. So that tells me I'm going to go to my decimal place and move 2 units to the right. Wow, not so bad. So 2.38 times 10 to the second is just 238. Let's take a look at a negative exponent value. 7.8 times 10 to the negative first. Well, negative tells me to move to the left, and I'm going to go 1 place value. So 0.78, or just 0.78. Either way is groove A. Here we go, we're back to another positive exponent here. So I'm going to look at 4.9. And now here, notice, I am going to move 5 decimal places, 5 place values to the right. So there's 1, 2, 3, 4, 5. So I have all these empty spaces here. I'm going to fill those in with zeros. Nothing, 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 nothing. So what 4.9 times 10 to the 5th is, as a number in standard form, is 490,000. That's all I'm looking for. And then finally, we have 1.23 times 10 to the negative 6th. So I'm going to start at my decimal place and move 6 units now to the left. We got 1, 2, 3, 4, 5, 6. So you'll have 1, 2, 3, 4, 5 zeros. So 1, 2, 3, 4, 5 zeros before your 1, 2, 3. There you have it. Let's now take a little look here at going backwards. So I'm going to give you a numerical value, and I want you to write it in scientific notation. So we're going to work backwards and go from a numerical value to a scientific notation value. So I'm going to move back until I find a C value, a number that is between 1 and 10. So here's how I'm going to do that. I've got 34,690. So here's my decimal, 0.0. So I am going to move this decimal back until I get a number that is between 1 and 10. So I'm going to go 1, 2, 3, 4. I'm going to stop right here, because if I stop here, I have got the numerical value of 3.469. 3 is a number between 1 and 10. It's at least 1 and under 10. So now I need to figure out what I'm going to write my power to. Well, I'm going to go backwards. Here's where I want the decimal to be. Now, to get back to its original location, it needs to move 1, 2, 3, 4 decimal places to the right. Since I'm going to the right, I will have a positive exponent of 4. So 3.469 times 10 to the 4th. Okay, I've got 0.039. So here, to get to a number between 1 and 10, I'm going to go, not stop there, but I will stop right here. So my leading C value will be 3.9. I'll have my times 10. Now, to get my decimal back to its original location, I'll have to move it 1, 2 to the left. So that would be an exponent of negative 2. There we have it. Question 3. I'm going to move till I get that number between 1 and 10. I'll stop right there. 7.22 times 10, and then my exponent going from my finishing position to its original location, I'd have to go 1, 2, 3, 4 to the left. So exponent of negative 4. And you can always work backwards if you're unsure. If you're at 7.22 and then have an exponent of negative 4, if you go 4 to the left, 1, 2, 3, 4, you would lead with 1, 2, 3 zeros, 722. So you're good there. All right, the big kahuna here. We've got 5,600,000,000. 2, 3, 4, 5, 6, 7, 8, 9, and I'll stop right there so that I have the numerical value of 5.6. 5.6 is between 1 and 10. So I said, to get from my scientific notation ending point back to my original location, I would have to move 1, 2, 3, 4, 5, 6, 7, 8, 9 units to the right. So my final notation would be 5.6 times 10 to the 9th. Hopefully you can keep those lefts and rights and positives and negatives straight. Get a little practice with that assignment and you will be in good shape. Have a good one.